Okay, so we'll walk through example 2.5. Again, solutions are already on OneNote, but hopefully this video will help answer any questions you have when simply looking at the work. So hopefully you've had a moment to read the example. If not, pause the video now and please read it, because I'm going to start with dissecting what you're reading. For instance, when you're told that p of x is divided by x minus 3 and the remainder is 7, that's actually telling me that if I knew what my polynomial was, if I plugged in 3, because of the remainder theorem, I know that I would get 7. So that pink business in the first sentence is telling me that I can actually write it as a point if I wanted to. That's 3, 7. And as I keep reading, it says when p of x is divided by x minus 1, the remainder is negative 3. So the same thing, it's telling me that if I knew what my polynomial was, and I substituted in 1 for x, I would get negative 3. So, I could also again write that as a point 1 comma negative 3. And then when I read this question of what is the remainder of p of x when divided by this product, I'm just going to rewrite that. What is, or find, r of x when a of x is x minus 3 times x minus 4. So if you've already watched the video for example 2.4, the previous example, I'm going to rewrite this as p of x equals, similarly to the last example, x minus 3 times x minus 1, that's your a of x, times q of x, plus r of x. And we're being asked to find the remainder again. So the difference now though is I don't actually know what my original polynomial is. But from what I've just written, a of x, if I actually expanded this, we know that this a of x has a degree of 2. So by the same argument, although it hasn't been scaffolded like the last example, we know that our remainder must have a degree of 1 or smaller. So again, ax plus b. So now that's where this other information comes into play. We'll use this other information, as in the p of 3 equaling 7. We'll use this similarly to what we did in the previous example. So when x equals 3, we know r of x equals 7. So therefore, I don't actually have to calculate p of 3. It's given to me. It's saying p of 3 equals 7. That's where a, and let me make sure I don't forget to substitute in x this time. That's 3 plus b. So like the previous example, that's one equation. And then the other information where they said p of 1 equals negative 3, that's saying when x equals 1, r of x equals negative 3. So like the previous example, negative 3 equals a, and again this time I won't forget to substitute in x here, times 1 plus b. So again, I've now created a second equation involving a and b. So the easiest way to do this is perhaps equation 1 minus equation 2, because when we go to subtract, 7 minus negative 3, that's 10 on the left hand side, equals 3a minus 1a, 2a, and then b minus b, that's what gets eliminated there. So we know very easily that a is 5. And then by back substituting, perhaps in negative 3 equals a plus b, probably didn't have to write that down, and you could tell me that b is negative 8. So restate the answer. As in, therefore, they asked us to find r of x, so therefore r of x is this linear result of 5x minus 8, which is what they asked us to find.